On June 25, 2024, China brought back rocks from the far side of the moon. No mission had ever done that. Then, in July 2025, 4 papers published in the journal Nature revealed what was inside those rocks, and the moon scientists thought they understood stopped making sense. The findings are rewriting 50-year-old models, and what they reveal goes far deeper than geology. That is what this video covers. The mission nobody thought would change science. Let's start with what made June 25th, 2024 different. For decades, every sample returned from the moon came from the same side, the near side, the side that always faces Earth. Apollo, Luna, Chang'e 5, 383 kilograms of lunar material spread across half a century of research, all from the same hemisphere. Scientists wrote textbooks, built geological models, constructed an entire story about what the moon was and how it formed. It seemed thorough, complete, but there was a problem nobody could fix. The moon has 2 faces. One points toward Earth, mapped, sampled, studied since the 1960s. The other, the far side, remains permanently invisible from every observatory ever built on this planet. And until June 2024, no mission had ever returned a single gram of material from it. Every model scientists had built about the moon's geology was constructed on evidence from one hemisphere only. Chang'e 6 changed that. On June 1st, 2024, the spacecraft touched down inside the South Pole Aitken Basin on the lunar far side, the SPA Basin. It is the largest, deepest, and oldest impact structure in the entire solar system, 2,500 kilometers wide, 8 kilometers deep at its lowest point. Scientists estimate the asteroid that formed it released energy roughly 1 trillion times greater than the largest nuclear weapon ever detonated. The lander drilled, it scooped, it extracted exactly 1,935.3 grams of rock and soil, leaving behind a sampling mark shaped like the Chinese character for middle, and launched them back into lunar orbit. Rendezvous, docking, re-entry. On June 25th, the capsule came down in Inner Mongolia. Scientists had the first far-side samples in history, and a year later, they told the world what was in them. In July 2025, the Chinese Academy of Sciences held a press conference. 4 research papers were published simultaneously in the journal Nature. Not 1, 4, each covering a different aspect of the same samples, each overturning something science had previously treated as settled. Here is what they found. Shock 1. The moon was volcanically active far longer than anyone thought. Scientists already knew from Chang'e 5 samples that the near side had volcanic activity as recently as 2 billion years ago, about 1 billion years later than models once assumed. That was a surprise at the time. This is bigger. The far side basalts show 2 distinct volcanic phases, 4.2 billion years ago and 2.8 billion years ago. That is a gap of 1.4 billion years, during which the far side mantle remains hot enough to generate lava, far longer than any model predicted for the far side specifically. The moon was not the simple, geologically dead world scientists had modeled. It was more complicated, more active, and the far side had been carrying secrets nobody could have found without these rocks. Shock 2. The moon's magnetic field came back to life. Around 2.8 billion years ago, the same moment as that second volcanic phase, measurements of ancient magnetic intensities locked inside the basalt revealed something nobody expected. The lunar magnetic field, which scientists believed had been in steady decline for billions of years, had rebounded. The moon has no global magnetic field today. Scientists assumed it had been weakening smoothly, continuously, for most of its history. This rebound, coinciding precisely with a second surge of volcanic activity, suggests the lunar interior was doing something far more dynamic than any model predicted. Nobody has a clean explanation for what triggered it. That question is still open. Shock 3. The far side mantle is extraordinarily dry. This is the finding with the most forward implications. The researchers measured the water content of the far side mantle source rock. The material these basalts are believed to represent lies deep in the lunar interior, far below the surface. The number? 1 to 1.5 micrograms of water per gram. That is the lowest water content ever measured in any lunar sample, anywhere. The near-side mantle contains meaningfully more. Researchers from Nanjing University describe this as the first direct measurement of water in the far side lunar mantle, and called it a milestone in lunar science. The far side is not just geologically different from the near side, it is chemically different, at the deepest level scientists can reach, in a way that directly involves the most strategically important resource in the solar system. Shock 4. One ancient impact rewrote the far side's chemistry entirely. The basalts from the SPA Basin show a mantle source that is extremely depleted in incompatible elements. The chemical fingerprints geologists use to understand how rocks formed and evolved. This depletion is so extreme, it points to one conclusion. The impact that created the SPA Basin didn't just scar the lunar surface. It reached deep enough to permanently alter the mantle chemistry of the entire far side hemisphere. Professor Mahesh Anand of the Open University in the UK, one of the world's leading lunar scientists, who has worked with Apollo samples for decades, said it plainly. These findings are turning many well-established hypotheses and theories in the field of lunar science upside down. 4 papers, 4 shocks, and the question underneath all of them is the same one. Why does the far side look so different from the near side in the first place? After 50 years of debate, Chang'e 6 provided the answer. The mystery they finally solved. For as long as scientists have had detailed images of the moon, one puzzle refused to go away. The near side and the far side look completely different from orbit. The near side has thinner crust, more volcanic plains, the dark patches called maria you can see from Earth on a clear night, richer chemistry, more water in the mantle. The far side has thicker, older crust, less volcanic history, a mantle that is chemically depleted and extraordinarily dry. The same moon, 2 completely different worlds. Scientists called it the Lunar Dichotomy, and for 50 years, the cause remained one of planetary science's most stubborn, open questions. Chang'e 6 closed it. The impact that created the South Pole Aitken Basin 4.25 billion years ago, which China's mission precisely dated for the first time, was not only a surface event. The asteroid punched through the lunar crust into the mantle itself. The energy released sent a shockwave through the moon's still molten interior. The moon was young then, largely liquid, crystallizing from the outside in as it cooled. The current best model is that the SPA impact disrupted that crystallization on the far side hemisphere, stripping it of the water-bearing, chemically rich material that eventually concentrated under the near side crust. The energy from the impact was 1 trillion times greater than an atomic bomb, and it altered the chemistry of an entire hemisphere permanently. One impact, 4.25 billion years ago. The consequence? Everything about the far side that puzzled science for half a century was written in that single moment. But here's the thing. Understanding why the far side mantle is dry does not mean the far side has no water, because there is a second place to look, and it leads somewhere else entirely. If you are learning something here, subscribe. We cover China's science and strategy at a depth most channels skip. Now, the part where the science and the strategy converge. The paradox nobody expected. The far side mantle is extraordinarily dry. That is now established science. But deep inside craters near the lunar South Pole, including craters that sit partly on the far side, craters so deep that sunlight has never touched their floors in over 1 billion years, the situation may be the opposite. The moon barely tilts on its axis. Because of that, sunlight hits the polar regions at an almost horizontal angle, almost sideways across the surface. Some crater floors near the South Pole are so deep, the sun never reaches the bottom at all. Not for a season, not for a decade, not for billions of years. Scientists call these permanently shadowed regions. Temperatures inside them can fall below -170 degrees Celsius, colder than the surface of Pluto on a warm day. Over billions of years, water molecules delivered by comets and water-rich asteroids that struck the moon drifted into these craters and froze. Never evaporated, never escaped into space, just accumulated, slowly, in absolute darkness for geological time. Current scientific models suggest these polar craters could hold anywhere from hundreds of billions to potentially trillions of kilograms of frozen water ice. Now consider what that actually means. Water is oxygen. Water is hydrogen. Water is breathable air. And hydrogen and oxygen combined form one of the most powerful rocket fuels humanity has ever used. The moon's gravity is only 1/6 of Earth's. If propellant can be produced on the lunar surface, spacecraft heading for Mars, for the asteroid belt, for the outer solar system could refuel there instead of carrying everything from Earth. The cost of reaching the rest of the solar system drops by an order of magnitude. The South Pole craters are not just scientifically interesting, they may be the most economically valuable real estate in the solar system. And China's next mission is aimed directly at them. What China is building next. China is not waiting for the science to conclude before the engineering begins. Both are running in parallel, on purpose. Chang'e 7, currently targeted for around 2026, is one of the most technically ambitious robotic lunar missions China has ever attempted. It is not a single spacecraft. It is a coordinated system, an orbiter, a lander, a rover, and something no country has ever operated on another world, a hopping probe. Instead of wheels, the probe is designed to leap, covering roughly 10 kilometers per hop, and descend directly into the permanently shadowed craters that wheeled rovers cannot safely enter. It carries an instrument called LUWA, the Lunar Soil Water Molecule Analyzer. Its mission? Find and confirm usable water ice in the exact craters the Mantle science suggests would hold it. Think about what that means operationally. These craters have been frozen and undisturbed since before multicellular life existed on Earth. A robot designed to leap into them is not a routine science mission. It is a prospecting operation for the resource that makes everything else possible. Then Chang'e 8, planned for around 2028. This is where exploration formally becomes infrastructure. At its center is a solar concentrator furnace. Using focused sunlight, it heats lunar regolith, moon dust, to 1,400 to 1,500 degrees Celsius, hot enough to melt it, hot enough to 3D print it into solid construction material. Layer by layer, at roughly 40 cubic centimeters per hour, landing pads to reduce the dangerous dust clouds during spacecraft touchdowns, radiation shields, protective walls, eventually, habitats printed directly onto the lunar surface from materials already there. No launch cost for building materials, no 400,000 kilometer shipping route from Earth. In November 2024, China began testing whether this works in real space conditions, mounting experimental lunar brick samples outside the Tiangong space station, exposed to radiation, vacuum, and the extreme temperature swings of low Earth orbit. And in May 2025, China and Russia signed a formal agreement to study placing a nuclear reactor on the lunar surface between 2033 and 2035. Standard solar panels cannot power a base through 336 continuous hours of darkness, the length of a lunar night. Nuclear power is the solution. The agreement was not exploratory. It was a construction planning document. The reconnaissance phase of the International Lunar Research Station program ends in 2025. The construction phase officially begins in 2026. The Endgame. Step back from the individual missions for a moment. The pattern they form is the real story. 2007, China orbits the moon. Basic mapping. 2013, first soft landing. 2019, the far side. 2024, samples returned from a place no mission had ever been. 2025, 4 papers in Nature, rewriting half a century of models. Each mission technically harder than the last, each mission making the next one possible. And the endpoint is explicit: China's International Lunar Research Station, led by China and Russia, with 17 partner nations as of April 2025, and its construction phase beginning this year, targets a permanent presence near the South Pole by 2035. On the other side of this stands the Artemis program. 66 nations signed to the Artemis Accords, NASA's first crewed lunar landing, Artemis 3, scheduled no earlier than mid-2027. Technical challenges with the Orion heat shield and SpaceX's human landing system have kept the timeline under pressure. But here's the thing, this race is not primarily about flags. Whoever operates near the South Pole first writes the early infrastructure standards, the communication protocols, the positioning systems, the resource extraction procedures, the physical layout of landing pads, power lines, and storage that everything built afterward connects to. Whoever arrives first does not own the moon. The Outer Space Treaty still applies, but the first mover holds the operational advantage. The same way the first port in a new harbor determines how everything else is built around it. The Chang'e 6 samples settled a question that puzzled scientists for 50 years. They confirmed that the far side mantle is dry, that one ancient impact shaped the entire hemisphere, that the moon's history is more violent, more dynamic, and more asymmetric than anyone knew. They did not settle who arrives at the South Pole first, or who builds the infrastructure that future missions depend on, or who controls access to the water ice that makes the rest of the solar system accessible. That question is still open. And based on the mission cadence China has held for 2 decades, the next mission's already funded, the bricks already being tested, the construction phase already underway, it is not idle. If this kind of depth is what you come here for, hit subscribe and turn on notifications. The next video goes inside China's nuclear reactor plan for the moon, what they are actually building, why solar power fails at the South Pole, and what the 2033 timeline really means for the race to stay there permanently. One question for the comments: do you think China or the United States will establish the first permanent lunar base? Drop your answer below.